Today we're talking about hypothesis testing, and we are going to look at the notes that I posted on Blackboard. If you go back into VoiceOvers, you can print the Chapter 7 notes to fill in with me. So pause your video and do that now. If you already did it, thanks for reading my suggestion. In Chapter 7, the whole purpose is to be able to test a claim about a value of the population's parameter. We want to do this for lots of different scenarios. One that I keep talking about is that I have a car manufacturer that claims that the car you purchased gets an average of 42 miles per gallon on the freeway. And if we want to run a statistical test to see if we can prove him wrong. So what would we be interested in proving? Because proving an exact value is pretty hard to do. So what extreme value would we be interested in? Well, we'd most likely be interested in proving that the population mean is less than 42. I don't know what that was. Thanks for playing. Alright, and so if this is what we're interested in, the other version would be that it's greater than or equal to 42. And you've just written your first two hypotheses. There's always two in the hypothesis test. There's a null hypothesis, which is the piece that always includes the equal to statement, and then there is the alternate hypothesis. These two statements are always complements to each other, and the null hypothesis always contains the equal to statement. So back up here, this would be our null hypothesis, and notice how I wrote it, and this would be the alternative hypothesis. This alternative hypothesis is what we are interested in, but this is the claim here. The null is the claim that the manufacturer is. So I'm going to run through the steps first. This kind of takes us through all of Chapter 7. So step 1 is stating the hypothesis. And so I've got some practice here for writing the hypothesis, and we'll come back to that in a minute. I think I kind of overdid it a little bit. Step 2 for conducting an hypothesis test is the level of significance. This is typically given to you, and it's kind of your error of your test, sort of. But values for alpha levels of 1%, 5%, and 10% are pretty common. So, but if you want to think about that as the error of your ways, that wouldn't be a bad thing to think about. The third step is deciding what test statistic to use. So you've already been practicing this in Chapter 6. So I'm asking here, are you going to use Z or are you going to use T? There is a third one that we haven't learned yet called chi-squared. And if sigma is known and you're looking for population mean, you use Z. If sigma is unknown, you use Z if n's greater than or equal to 30, and T if n's less than 30. Now, the book's a little shady on picking and choosing these, but the one thing that your book doesn't alter on is that if sigma is known, it's Z. Now, you still have to have a normal distribution, or you cannot use either one of them, and we're talking about a senior level stats course. Okay, so we're going to assume normal distribution if it doesn't tell us, unless we're on my math lab, because it will ask which one to use. Okay? Alright, so for a hypothesis test about population proportions, you always use Z unless the sampling is too small. And our book's guidelines are that n times p is greater than or equal to 5 and n times q is greater than or equal to 5. Chi-squared is for variance in population. I've chosen for time restrictions not to cover that in this course, but we will see a very common use for chi-squared before the semester ends. The next step in running a hypothesis test, so step 4, is finding the test statistic. So for example, for means, you would have Z is x bar minus mu over sigma divided by the square root of n, and that would find your z-score. Your t-score, or your t-stat, is found almost identically. It's x bar minus mu over s divided by the square root of n, because sigma is not known. And then we'll talk about proportions in another video. Step 5, find the p-value. So what the heck is a p-value? P-value is your probability that this scenario is going to happen. So if you look here, based on your hypothesis test, your p-value would end up being a probability statement about either z or t. So for example, it might be that the probability that z is greater than 2.5. Or maybe it's the probability that t is less than negative 1.4, something like that. And if you have a two-tailed test, which we haven't talked about yet, but if you have a two-tailed test, then you just double that probability. So it would still be z is greater than 2.5, but you would do 2 times whatever that area is from your chart. Okay? All right. Now, that's the overview for the hypothesis test, and you've done all of that already, except for this doubling piece here in this particular instant. The next step is comparing your p-value to your alpha level, and this will make more sense the more examples you see, but your textbook has 2 ways of running hypothesis tests, and I choose to do the p-value way. I think it's the least confusing and more systematic. So when you're done and you found this p-value, then you compare it to your alpha level. And that's about it. And then you make a decision. So ta-da! That's the overview. In the next video, we'll practice writing hypothesis tests and deciding if we have a 1 or 2-tailed test. And depending on the time of the video, I will actually run a hypothesis test. Awesome introduction. Thanks.